In this video, we explain what is the expression of Atrio-hisian accessory pathways. Atrio-hisian accessory pathways bypass the atrioventricular node. During sinus rhythm, they may exhibit a PR interval that is either short or normal, more frequently normal than short. Finally, they may participate in atrioventricular reciprocating tachycardias that are usually taken as AV nodal reentry tachycardias of the common type, the so-called slow-fast AV nodal reentry tachycardias. Atrio-hisian accessory pathways do not produce ventricular pre-excitation. Depending on how proximal is the connection of the bypass tract in relation to the origin of the bundle of His, we will have two different scenarios. In A, we represent the situation in which the Atrio-hisian bypass inserts proximally in the bundle of His. This type of Atrio-hisian bypass tracts will present a short or relatively short AH interval that does not prolong significantly after atrial premature beats or with atrial pacing at increasing rates. In B, we represent the situation in which the Atrio-hisian bypass inserts more distally within the His bundle. In this situation, we will see a short or relatively short HV interval that is constant either during sinus rhythm or following atrial premature beats or during atrial pacing at increasing rates. The AH interval in this situation will be longer as compared to the previous scenario, but it might be either normal, the AH, or even short. The AH will not prolong also significantly with atrial premature beats or with atrial pacing at increasing rates. These three panels belong to a patient that had a supraventricular tachycardia that was felt to be based on an AV nodal reentry mechanism. The three panels illustrate right ventricular programmed electrical stimulation introducing progressively more premature single ventricular extra stimuli. Note that each ventricular extra stimulus was retrogradely conducted to the atria. Also note on the right that the H2-A2 interval was constant, always 30 milliseconds after each ventricular premature impulse, independently of the duration of the preceding V2-H2 interval. In this screen, we show tracings from the same patient discussed on the previous slide. We see that the H2-A2 interval during programmed ventricular stimulation, 30 milliseconds, is identical to the HA interval during the atrioventricular reciprocating tachycardia. This is not consistent with an AV reciprocating tachycardia using anterogradely a slow AV nodal pathway and retrogradely a fast pathway, but is more compatible with a reentry mechanism that uses the AV node in the anterograde direction and then Atrio-hisian bypass tract retrogradely. In a classical AV nodal reentry tachycardia using an anterograde slow and the retrograde fast pathway, the HA during right ventricular pacing is longer than the HA during tachycardia. The reason is that during right ventricular pacing, the HA equals the conduction times via the lower common pathway plus conduction times via the fast pathway plus conduction times via the upper common pathway. While during binodal reentry tachycardia, to reach the bundle of His, you have to proceed through the lower common pathway, and during this period of time you have traveled through a certain distance within the fast pathway. Therefore, the HA during the binodal reentry tachycardia equals the conduction times via the fast pathway minus the conduction times via the lower common pathway plus the conduction times via the upper common pathway. In the next video, we will discuss the conducting properties of accessory pathways.